Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at lesson 5.3.1. These next four lessons, the second part of chapter 5, is all about problem solving, and it is all about what CPM likes to refer to as the as the 5D process. And a lot of times when students see this 5D process, they think, oh no, it's new math, it's a new way of doing things. CPM has invented something, and now we're expected to change how we've always solved problems and figure out a new system, and if this is so hard. And I'm going to say no, 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 and no. It is just problem solving. It's just basically giving you the 5Ds as a way of remembering what everybody has always done whenever they went through the problem solving process and did it effectively. Okay, so the fact that they're calling it 5Ds gives you, those things to try and remember. But we're not there yet. It's not today. That's going to be the next lesson. Today, we're just going to do an essential aspect of problem solving, and that is reading into situations and trying to determine what it is that we're working with and what it is that we need to figure out, and how by just changing the wording around a little bit in sentences can actually affect the entire meaning. Okay, so today's goal is for us to be able to look at situations and be able to describe a relationship between different quantities. Okay, so you may not know it, but you use mathematical thinking every day. You think mathematically when you figure out whether you can afford items you want to buy, or when you read a graph on a website. You also think mathematically when you double a recipe, or when you estimate how much longer it will take to get somewhere based on how far you still have to go. Math can describe many of the relationships in the world around you. Building your interpretation skills and developing ways to represent situations will help you solve problems. In this section, you will learn new ways to show your thinking when using math to solve problems. As you work today, think about these questions. How can I represent this with a diagram, which is one of my favorite questions because I love drawing and making a visual of situations to help better understand them. And then who has more and who has less. All right, so sometimes using the same words in a slightly different way can change their meaning. Read and compare the two situations here. So here's situation one, which I have illustrated over here. It says Myra has 15 marbles. Here's Myra, 15 red marbles. This is 10 less than Dahlia. And here's situation number two. Let me scroll down a little bit so you can see it. It says Myra has 15 marbles. All right, same as situation one. Dahlia has 10 less than Myra. So here's Dahlia's marbles. So notice slight changing in the wording of the second sentence has changed the relationship between the number of marbles that Dahlia and Myra have. So for each situation, draw a picture. Go ahead, feel free to copy those down. And then what is the difference between the problems? And then in which problem does Myra have more marbles than Dahlia? And then the last question, how many marbles does Dahlia have in situation one above, and how many does she have in situation two? So what I would like for you to do is pause the video, go ahead and create the diagram, the picture that states due in problem one, and then answer each one of these questions, and then I will do the reveal after you've had a chance to think it through, to formulate your answers, and then you unpause. Okay, so pause for a little bit, get all those figured out to the best of your ability. Don't worry about if you get some answers wrong, it's totally okay. You can always pause and then erase and fix the answers once I do the reveals. Alrighty, let's take a look. It says for each situation, draw a picture to represent the marbles in each row has. What is the difference between the problems? Well, come on, dude. Why are you not leaving? There we go. Delete. Oh, sorry. It's very frustrating. What is going on here? I don't want. There. Go. Okay. One says this is 10 less, situation one, and the other one says Dahlia has 10 less. And so those subtle changes between the two situations makes a big difference for how many marbles that Dahlia has. Which problem does Myra have more marbles than Dahlia? Well, that would be situation 2, right? When Myra has 15 and Dahlia has 10 less, that means that Dahlia must have 5. She has 10 more in situation 2. And how many marbles does Dahlia have in situation 1, and how many does she have in situation 2? Well, it looks like she's got 25 of them in situation 1, which is 10 more, right? Well, I guess what Myra had, 15 was 10 less than what Dahlia had, so she must have had 25 because 15 is 10 less than that. And there you go. Situation 1, she had 25 marbles. Situation 2, she had 5 marbles. So just by subtly changing around wording, you get a completely different meaning for the situation. All right, Ellie is building a dollhouse. She has boards that are 2 different lengths. One board is 7 inches longer than the total length of 3 of the short boards. So if you look at this, you can kind of see, okay, now I guess I was going to be sort of ambitious in this lesson, but I have to explain something to you. I left my Moby at school, which means I have no ability to fluidly write on any of this. So I've taken the time to create the images, but I'm not going to be able to do some of the writing and stuff that I would like to do. And even if I try, it's going to be so frustrating that it's just not going to work very well. So, just kind of listen to what I'm saying and think about the relationships here. Okay, so got that qualification or that whatever. I don't know what I'm saying. I got that out of the way. So it says draw a picture. Maybe I better read what's in green again, just to start over. One long board is 7 inches longer than the total length of 3 short boards. Okay, so here are the 3 short boards. The total length of all 3 of them, put end to end, you would add all 3 of those together. And then here's the long board. So in this situation, we have 2 different variables. We have the length of the long board and the length of the shorter boards. And you could call each one of these X's, you could call this Y, or you could write an equation or an expression to represent this situation. So it says draw the picture. So there's the picture. You can just copy that down. And then it says, what are some possible lengths of her boards? And so in this situation, there could be anything, right? Because there's no information in here that tells us the total length of all the boards put together. So you could say, well, each one of these were 1, and this would have to be 7 more than 3, right? Because 1 plus 1 plus 1 is 3. 7 more than 3 would be 10. So this could be 10, and each one of those could be 1. Or each one of these could be 5. So it'd be 5, 10, 15. So this would have to be 22, since 22 is 7 inches longer than 3 of these put together. Okay, so you come up with a possible combination of the different lengths. And then the next part, if one of the long boards, one of these is 50 inches long, what would have to be the length of each of the short boards? See if you can figure that out. Go ahead and pause. And you know there are an infinite number of possible answers for B. Just make that your answer is correct, one of those infinite ones, and then solve and answer question C. All right, so there's so many different answers. I'm going to trust that you got this correct. I just came up with one random answer where I said the short boards could each be 10 inches long, which would be a total of 30 inches, and then that would make this one 7 more than 30 inches. The long one would have to be 37 inches. Okay, so you may have gotten the same one as me. You might have gotten something different. Totally okay. So now, if one of the long boards is 50, how long would the short boards be? So let me go ahead and show the work first, and then I'll declare the answer. This is how we would set this up. If we were to say, oh, wait, hold on for one moment. Hold on. Got it. Okay. If we were to say that longboard was 50 inches, then these 3 plus the 7 would have to be 50 inches long, right? So the expression for the short boards is X for each one of them, right? This is an X, this is an X, if this is an X, because we don't know their length. But we know that all 3 of them put together would be 3 X's. Plus an additional 7 inches added onto those would equal the length of the longer board. So rather than say this is a variable, the longer board, they've actually told us its value, it is 50. So all 3 of these plus an additional 7 inches would be equal to the 50 inches of the long board. So we'll now use some algebraic reasoning to figure this out. If you took away these 7 inches and just cut that portion off of the board, then these 3 added together would have to be equal to 43 inches, correct? Because you would take away the 7 inches from the 50 inches, leaving you with just 3 x's is equal to 43. Then if you divide 43 inches into 3 equal sections, how much would each equal section be? Well, 43 divided by 3 ends up giving you an answer of 14 1/3 inches, or 14.3 repeated. So if the long board is 50 inches long, then the short would be 43 1/3 inches. All right, now let's talk about Diana and Hiro. Let me go ahead and get rid of this guy right there. Okay, so problem A. Diana has $16. Hiro has twice as much money as Diana. Who has more money? Problem B says Diana has $16. She has twice as much money as Hiro. Who has more money? Okay, so what we're going to start with is representing a diagram for this situation, and then declare these answers. So the diagram for A would look something like this. Okay, if we took the amount of money that Diana has and write it as a diagram, then Hiro would have twice as much, right? So he would have to have 16 times 2, which would be 32. So who has more money in this situation? It must be Hiro. He's got 32 to her 16. In problem B, it says that Diana has $16 and she has twice as much as Hiro. So the diagram that would fit for this situation would be, here's Diana on the bottom, right? 8 and 8 make 16, and Hiro has half as much, so he would have 8. And so in this situation, we've got a Diana that has more money. So compare the amount of money that Hiro has in part A to the amount that he has in part B. Explain how you know in which situation he has more money. Okay, so go ahead and formulate your thoughts and write down a response, and I will reveal what I have for my explanation in a moment. Alrighty, so explain how you know who has more in each situation. So let's take a look in problem A. The situation is that Hiro has 2 times 16, right? Because Diana has 16 and he has twice as much, which means 2 times as much as her. So he must have $32. And in problem B, Diana still has the $16, but that is twice as much as Hiro, which means that Hiro has half as much, which is half of 16, which means he must have 8 in that situation. All right, and I believe these are the last 3 problems. Let me go over here and check. No, I guess we got something else happening at the end. All right, so what we're going to do here is it says now you're going to reverse your thinking. Examine the pictures below, then use words to describe the relationship you see within these pictures. Assume that that the lengths that appear to be equal are equal. Okay, so we're going to say that those, I think, are toothpicks, and so each one of those toothpicks is the same length. These are bricks that appear to be the same length, and they are. These are, or maybe those are pieces of wood. And then these are the same thing, longer pieces of wood that appear to be the same. Each of these boxes should hold the same number of cookies, and each one of these cookies is the same size. Okay, so go ahead and take some time and see if you can formulate a statement that can be used to describe each one of these situations presented in parts A, B, and C. Unpause when you feel ready, and then I will reveal pretty much the answers and what I feel the relationship should be. And there could be some situations where you might describe it slightly differently, but the way that you describe it is actually correct, and there could be more than one way of interpreting a situation. But ultimately, they end up both describing the same situation. Okay? Okay. So let's go ahead and pause and spend some time on that. All right, see what we got here. So what I'm noticing here is this. I'm noticing that you got 2 of the short boards and 2 of the long boards. And this basically says that 2 long boards are 10 inches longer than 2 short boards. So that's what I wrote for my statement to describe that. For part B, we've got three different variables, right? You've got the shorter side, you got the longest side, and then you got the side in the middle. You can just easily say side 1, side 2, and side 3. So there's a relationship between side 1 and side 2, where side 2 has twice as many, are those toothpicks? Not quite sure what those are. Twice as many of those things, or maybe we'll just call it twice as long, side 1. And side 3 is one more unit than side 2. So I said side 2 is twice as long as side 1, and side 3 is one more than side 2, whatever we're calling those units, whether we're calling them toothpicks or units or whatever. I don't know. And then part C, this is an interesting one because it says these have the same number of cookies. So this diagram has an equal number of cookies with this diagram. So it might be good. Like if we were just creating expressions, you know, we could create an expression for A and for B, but for C, you're actually creating an equation since this is equal to that. And we would include that in our equation and then solve. So what do we notice here? 3 boxes plus 2 cookies is the same number of cookies or is equal to 1 box with, what is this, 5, 10, 15, 20 cookies? So 3 boxes plus 2 cookies is equal to 1 box and 20 cookies. Now, here's the question for you, which without going on too much further, can you tell me how many cookies are in each one of those boxes? Could you do that right now just by analyzing the situation? First thing I would do is this, is I would take away 1 box of cookies from the left and 1 box of cookies from the right. So that would leave me with 2 boxes plus 2 cookies is equal to these 20 cookies. Then I would take away these 2 cookies and 2 of these cookies. So that would mean that 2 boxes is the same as 18 cookies. So if you got the same number of cookies in each box, that would mean that these 2 boxes would each have to have 9 cookies in them. 9 plus 9 plus 9 is 27, 28, 29, and 20 plus 9 is 29. There you go. We just used some algebraic reasoning with the numbers of cookies to add the numbers of boxes to figure out how many cookies are in each box. All right, last problem. Rich, Ariel, and Kristen measured, or just measured how tall they were in feet. Their heights are shown in the bar graph to the right. Decide which statements below are true and which statements are false. Rewrite the statements to make them true if they are indeed false statements. Okay, now, I did something here, a little bit of trickery. I have created a bunch of boxes here, and some of them are covering up answers, and some of them are covering up non-answers, because I don't want you to know which ones are false and which ones are true just by looking, although I see a little bit of writing right there, and that's cheating a little bit, so hold on for a second. Now you have no idea which ones have writing underneath the boxes and which ones don't. It was magic. Okay, so go ahead and let's answer each one of these questions based on what you see there. Rich is a foot tall, or 1 foot shorter than Kristen. Is that true or is that false? Clear your answer. Ariel is twice as tall as Rich. Is that true or is that false? Go ahead and declare your answer. And by the way, if either one of those are false, please rewrite the statement as a true statement. Kristen is 1 foot taller than twice Ariel's height. Is that true or false? And then the sum of the 3 children's height is 10 feet. Is that true or false? Go ahead and declare your answers, and the ones that are false, please rewrite the statement so that it is true. All right, let's take a look at this. Rich appears to be 4 feet tall, and Kristen appears to be 5 feet tall. So is Rich 1 foot shorter than Kristen? Yes, he is. That is a true statement, so there's no reason to make any correction there. Ariel is twice as tall as Rich. Is that a true statement? Is she twice as tall? No, she's shorter. That's a false statement. And what it should say is she is half as tall as Rich, or Rich is twice as tall as Ariel. Either one of those would be true statements. Kristen is 1 foot taller than twice Ariel's height. 1 foot taller than twice Ariel. So Ariel is 2. So if you double it, that's 4, and add 1 more, that's 5. That is, in fact, a true statement. So no reason to change anything there. And the sum of the three children's height is 10 feet. Well, let's add them together. 4 and 5 make 9, 10, 11. No, they are not 10 feet. That's false. They are actually 11 feet in height total when you add all three of them together. All right. That is it for our lesson for chapter 5.3.1. Let's go ahead and move on to our next activity, which I believe should be completing homework. Take care. Bye.
Hey, feeling good.